So what is the original pattern? Just square the inputs to get the outputs. What will this quadratic function look like? When we put on the inputs, what outputs will we get? Without going to the trouble of actually plugging in x values and calculating, we know that they are going to be the same outputs as the original, except each of them is going to be cut in half because you times by 1/2 at the end. So if we plug in a 2, we would have gotten a 4, but now it'll be 4 times 1/2 is 2. Half of 9 is 4.5. Half of 1 is a half. Half of 0 is 0. And same on the other side. Sometimes it's better to express these as fractions, but we'll stick with decimals for now. Let's try out one more quadratic function, and then we'll do something a little different. What will happen with the quadratic function y equals x squared plus 1? Let's plug in a few values for old time's sake. When plugging in values for x, notice I almost always put parentheses around the number I'm plugging in. This ensures that if you have a negative, it will be squared, and you'll get a negative times a negative is a positive, and it can come in handy in all situations. So if x equals 0, we get y equals 0 squared plus 1. 0 squared is 0, and when we add 1, we get 1. If we plug in a 1 for x, we get y equals 1 squared plus 1. 1 squared is 1, and 1 plus 1 is 2, so when we plugged in a 1, we ended up with a 2. If we plug in a 2 for x, we get y equals 2 squared plus 1. 2 squared is 4, and if we add 1, we get 5. And let's look at what's happening. We're taking our x squared and we're adding 1 to it. So when we plugged in 0 before, we got 0. Now it's 1 above 0, which is 1. Here we got 1, now it's a 2. Here we got 4, now it's a 5. Here we got 9, so this will be a 10. And the same thing will happen on the other side. Another thing to notice is that this last quadratic function had an x squared term and a constant term, but it's still a quadratic function because of the x squared term. We've spent a lot of time taking simple quadratic functions, making tables out of them by plugging in inputs and getting outputs. Remember, every input-output pair can make a coordinate point, which is an x, y.